This section concerns periodic functions. A function is periodic if its values repeat at regular intervals. We'll be studying a lot of periodic functions. When it says it repeats at regular intervals, in math symbols, that means if your function is f of t, then it is equal to f of t plus c. So that this c is the smallest positive value where it repeats, where the values repeat. So we'll look at a lot of different examples of this over the next sections, but let's first look at one application problem. What we have is a chemical reaction, and the temperature oscillates over time from a low of 30 degrees centigrade, and we start counting at 0. The reaction may have been going on a while, but when we observe the reaction, we're starting to count, so we call it t equal to 0 hours, and we start counting at the low, 30 degrees. The next high, it hits is 110 degrees, but we don't know the time that it hits that high. We do know that the middle temperature is reached at 2 hours, and we're trying to determine the period. Now, this is a regular oscillation, up and down and up and down. And it's hard to see these usually with words, so let's put it in a table. Let's have a little t for the time and a capital T for the temperature. And we know that when t is 0 hours, we hit the low of 30 degrees. Now, after the low comes the middle, and we don't know what the middle is, but it happens at 2 hours. And then we hit a high, and that is, we don't know what time, but it's 110 degrees. So let's think about this before we keep going. It says it oscillates, and in the lesson you'll see it oscillates in a regular symmetric fashion. So it starts at a low, hits a medium, hits a high, and since it's regular, that's in another 2 hours. And then as it drops from the high, it hits the medium again, the middle temperature, 2 more hours. And then it drops and hits the low. Let's see, I think I'll take the degrees off of here. We know it's degrees centigrade, and I'll just work with numbers. So this must happen at 8 hours. Now, what happens after that? Well, when you hit the low, then it starts back up again. So we've got the middle at 10 hours. So if you think about this, I haven't actually found the middle temperature, but the way it has to oscillate from a low through the medium to the high, back to the medium, to the low, to the medium, this is where it starts over. So since it starts at 30 at the low, and when it hits 30 again, that's the repeat. So our C would be equal to 8. 8 is the period. It's 8 hours is the period here. Let me say hours. Well, 8 is the period, so I'd say period of reaction is 8 hours as the temperature changes. Now, you're welcome to find the middle temperature. You don't really need it here. If you were looking to find the middle, you would just take the average of these two. 30 plus 110 is 140. The average of that would be 70. So if you think about it, from here to here is 40 degrees, and from here to here is 40 degrees, so 70 is the middle temperature. But I didn't even need it for this problem. This is all we need to know. What is the period? And the period is 8 hours. In this example of a periodic function, we're looking at the graph. It's supposed to be oscillating regularly and symmetrically. I start at the low point. I go up and down several times. Now, the period of the function is 8 hours. So when we look at this, we have to look at the graph and determine when it starts to repeat. So we start at 0 here. That'll be t equal to 0. It goes up and then down. And at this point, it starts to go up and down again. So this piece right here is one period. That's the way the entire function looks, and then it repeats that. So this would be 8 hours. So how many times does it oscillate? 1, 2, 3, 4, 5, 6. So since it oscillates 6 times on this graph, and the period is 8 hours, then what is shown is, or 6 times 8, 48 hours are shown. Because I just have to count the periods and multiply the period times the number of times it repeats. This is said that it's regular and symmetric, so that it does look the same. You'll see this in the lessons. The previous problem that we looked at started at a low of 30 degrees Fahrenheit for that chemical reaction and went up to a high of 110. And that would actually fit this here where I have an 8-hour period. So my midpoint here and a high and a low kind of shows you that it is a regular every 2 hours from the low to the mid to the high to the mid back to the low again, and that takes care of your 8 hours. Here's another graph, and this time the question is slightly different. We're told the period of the function is 8 hours, but we want to know how many periods are graphed. And there are a couple of ways you can think about this. You may be tempted to start at a low point, even though that's not t equal to 0. This would be t equal to 0. You could start at a low point and figure out where the period goes. You could start here and figure out where the period is from that point. We've looked at the period starting at the bottom, at the low, up through a medium to a high, back to a low. So you could say that I've got one period right here, and then it begins to repeat. So that would be 1. If we start here, 1, 2, 3, 4, but we have another piece of it back here, so we have to count this. And you might say, well, that's 4.5 because I'm up halfway. This is supposed to be the middle. It looks a little low, but this is supposed to be the middle. So you might say, okay, that's 4.5 periods. But let's double check this. 4.5 periods. That's our first thought. Let's start here and go from here up to when it hits that point and begins to repeat would be here. Okay? So this would be 1 period. And again, to here where it begins to repeat going down. Okay? See, it goes up, goes down, and then up, and then down, and then it starts to repeat. So it goes down and up and down, and then it starts to repeat again to here, up and down, and starts to repeat here. Okay, so we have this little piece left over, but remember it went down and up and then down. So if we get to the end of the period here and we go down, we're missing the up and down again. We don't have a half of a period. That's not correct. We only have a fourth of the period. From here down to here is one piece, middle to low. From here to middle is the second piece. Middle to high is the third piece. And down to here is the fourth piece. So basically, sorry, I draw kind of off. Pretend like these are the same. 1, 2, 3, 4. It takes 4 pieces to make up one period. As you go from the middle to the low to the middle to the high, back to the middle to start over. So when I ended the period here, all I have left is one piece. It's not 4.5 periods. It's 4.25 periods. So you could say it's 4.25 or 4.25, but you have to be very careful that you actually do include everything you've got in your graph. Here we have an application of a temperature in an unopened freezer that oscillates. And it oscillates between -3 degrees Fahrenheit and 2 degrees Fahrenheit. The minimum temperature occurs at 1 o'clock and the next maximum at 1:20. The period is 25 minutes and we want to make a graph of this function. So we're going to start our graph at 1 o'clock. Okay, not 0. 1 o'clock is our 0. So we're going to start at 1 o'clock here and figure out what our times are. Now, if the minimum occurs at 1, then this is the minimum of, I need to make that longer, maybe a little straighter. Okay, at -3, so we'll call this -3, and this is where it starts. And at 1:20, we hit the high. So I'm going to call this 1:20. And the high is 2 degrees Fahrenheit, right here. So I go up and hit the high at 1:20. Didn't quite make it, did I? I'll curl it over there. We'll see how that works. But the period is 25 minutes, and it's already gone 20 minutes. So when I get over to 1:25, it's already back at the minimum. It's already back down here at 1:25. So I think I need to redraw this a little bit because it's a big drop off. So it goes here up to 2 at 1, and then it drops down here at 1:25. So this is not one of those oscillating regularly and symmetrically. It takes longer to get to the high temperature, and then it drops to the low. So we have another 20 minutes. So let's count here. 20 minutes after 1:25 would be 1:45. So after I hit here, if I'm doing units of 20, here to here would be 140, and this would be 145. So after 20 minutes, it goes up, back up to 145, to the maximum. And then 5 minutes later, which will be at 150, it hits the bottom again. And you can continue to do that. The units look kind of strange because we have to count funny, it seems like. So we hit the high 20 minutes after the low, and then it drops for 5 minutes, and then 20 minutes after that, which would be 20 minutes after 150, it would go up again and then drop. So this is very symmetric, not symmetric. It's within the period, it's not symmetric because it doesn't happen regularly. But this is what the graph looks like. So be very careful when you read your graphs and to think about it can oscillate, it can be periodic because this repeats every 25 minutes, but it doesn't have to be a pretty smooth curve when you graph it.